Thank you, Adrian, for that introduction. We're excited to be here, Caterpillar being a sponsor of the event, and I'm honored to be up here with so many distinguished speakers from the industry. I think this is a great conference and a great opportunity for us to talk about what's going on in renewables and in the mining industry. Mining is a huge part of CAT's business. We're about a $50 billion a year company, and mining is typically represented about a third of our overall businesses: mining, construction equipment, and then energy and transportation. And of course, with the mining decline, we've seen an impact to Caterpillar, as have many of the mining customers. And then with the oil and gas decline, we've also seen an impact there. So it's tough times in the business, but I would say there's always been cycles, and we're optimistic and hopeful mining is on its way back up, and I think Caterpillar is ready to respond despite the cycles. There's always a trend, and I think the trend line for all of our businesses is very positive. I really want to talk about three things this morning. I want to talk a little bit, it was mentioned earlier, about some of the impact of these exponential technologies and what it's doing to our business and to, I think, all of our businesses out there. The rise of renewables, I think it's evident, and I think just in a few short years, we've seen a huge increase in the amount of renewables and their economic attractiveness globally. And then our commitment to both the mining industry and really helping miners reduce their operating costs, which is the topic of the presentation, if I can figure this out. So let me talk about realities in the world today. I mentioned it earlier. The rate of change in our business is accelerating. The business cycles are becoming shorter and probably steeper. And I think there's an overall trend, if you just look at society and technology, in terms of exponential technologies and where that's headed. Back in the early 70s, I don't know if you're familiar with Moore's Law, but Gordon Moore, the founder of Intel, predicted that the number of transistors in an integrated circuit would double every 2 years. And it's kind of become a famous thing now, because if you look at the reality of that, it's really held true for that, and I think many other technologies. In 1971, the Intel 4004 microprocessor had 2,300 transistors, and in 2012, the current technology has 7.1 billion transistors, is 10,000 times faster, 10 million times cheaper, basically 100 billion-fold improvement. They're predicting now that computers by 2023 will have a $1,000 computer will have the capacity of the human brain in terms of processing speed, and that by 2050 computers will be processing information equal to the entire processing capability of mankind. So the reason I bring this up is because I think that technology and the change in technology, in not only computers but in many other fields, artificial intelligence and 3D printing and other things, are coming at us quicker and quicker. And as companies, we really have to adapt, and we have to be more innovative. And to a large degree, I think our brains aren't really wired for it. We've developed thinking linearly as humans, and if you think about 30 paces and how far 30 paces are, it's all pretty easy, right? 30 paces is about 30 meters. If you take exponential paces, basically doubling each time, 30 paces is, and I'll get this right, 1,730,741,824 meters. Enough distance to circle the Earth 26 times. What that means is that with these exponential technologies and that are coming at us, that we really don't comprehend them, and we generally are behind the curve. A good example of that is Kodak. They actually Steve Sasson invented the digital camera while at Kodak. Showed it to his bosses, and they looked at it and said, it weighs 8 pounds. It's got 0.01 megapixels and takes 23 seconds to process a photograph. I said, hey, this isn't going to go anywhere. Film technology is going to be around forever. 1999, they were a $28 billion market cap. They had 140,000 employees, and by 2012, they were bankrupt. They didn't see the potential of digital photography and the exponential growth in the technology. It was deceptive. That same year, Instagram, 13 employees, had a market cap of $1 billion and was growing exponentially. So I think the message here is really one of innovation and maybe in strong words, you either innovate as a company today, you take advantage of some of these new technologies, or you're not going to be around long. Richard Foster, a Yale professor, basically observed that if you go back to 1920, the average lifespan of an S&P 500 company was about 67 years, and today it's about 15. So for Caterpillar and for, I think, all the companies in the audience, we really need to take advantage of these technologies. Our CEO, Doug Oberhelman, basically made the comment, we got to start thinking outside the machine. We've got to look at ways to not only look at what our machine does, but how it interfaces with other things outside of it, and look at some of these disruptive technologies. And in mining, autonomous vehicles, it was mentioned earlier today, and I think electric vehicles fit into the same category. We've been developing those for years. We're not too far away. We've got some mine sites running today. But with what's going on with LiDAR and Google cars and self-driving automobiles and the price of that technology and where it's headed, you can expect to see more and more of that in our mine sites moving forward. I think on any of these technologies, and it was brought up earlier today, the social ability for us to deal with technology change socially is probably as big a challenge as integrating the technology itself. 3D printing. Today you can buy a 3D printer for $300. The technology and the cost of it's come down dramatically. I don't think we're too many years away from 3D printing parts instead of having to transport them to your mine sites around the world. Just recently they had 3D printers operating in outer space. And I don't know if anybody's concerned, but some of the folks in Silicon Valley are actually investing in and laying claim to asteroids in outer space so that they can harvest the rare earth metals and produce things with 3D printers up there. The Internet of Things is probably one of the biggest opportunities for all of us in terms of collecting data. I think it's now projected that by 2020 there will be 40 billion interconnected devices or devices connected to the Internet. Obviously at a mine site you've got a lot of devices, the microgrids being part of it, but all of the equipment. And it's an area for all of us, I think, to look at that data and understand how we can improve operations and efficiency. Machine learning, artificial intelligence. Caterpillar just recently invested in a company called Uptake, really taking all this data that we're collecting from machines and really applying kind of state-of-the-art fast learning algorithms and analytics to try to understand how we can improve not only the predictability of our machines and failures and operation maintenance, but also how we can improve overall efficiency of our customer sites. And then finally, energy. Tremendous amount of things going on in energy. That's part of why we're here. Obviously, the reduction in price in both solar and in wind. But energy storage is an area where there's tons of money being invested and lots of new technologies being developed. So why do microgrids make sense, and why is Cat in this business? Just as a disclaimer, I do want to say that Caterpillar still does make diesel engines and does make gas generator sets and is investing a lot in those technologies, improving their efficiencies. But clearly, for remote locations for most of the world, wind and solar have decreased in pricing dramatically over the last 15 years. That trend is continuing. We've seen solar since about 2011 drop about 60% in terms of LCOE, and solar panels have dropped over 90% from 2007 and 2015. Today it's projected that about 48% of all the capacity put on the electrical grid will be renewables from between now and 2040, so nearly half of all the energy produced, and that may even go faster depending on regulations. I think 164 countries today have either feed-in tariffs or some sort of target that they're trying to achieve in terms of renewables penetration. I put this chart together with some trepidation. I don't want to get hung up. There's obviously lots of people in this room who can point, holes in this, and there's a lot of assumptions that go into this data, but I use it just for illustrative purposes, really to kind of outline what we see in the market today. And again, each mine site, each location is different, each customer is different. But in general, if you look at this chart in terms of levelized cost of energy, in terms of cents per kilowatt hour or dollars per kilowatt hour, in general, renewables for remote sites make sense and are more competitive from a cost per kWh standpoint than traditional diesel generation and gas peaking. And the curves there largely, or the bars on traditional generation really relate to the cost of getting the fuel there and that sort of thing. If you've obviously got a natural gas pipeline close to your facility, your cost could be even lower than that. But if you've got to transport it in, it could be more expensive. I pointed out because you see a lot of stuff in the press about large wind, utility scale solar having very, very low numbers. That's true. We've seen a lot of reports of 6 cents per kilowatt hour, large scale farms. There's a lot of reasons for that. Obviously, land is probably free. The weighted average cost of capital is very low. You've got efficiencies of scale on those large scale projects. We haven't seen that yet really in the smaller scale, the commercial industrial or microgrid kind of projects. We're talking about more of the 12 to 18 cent range when you've got probably a higher cost of financing, which is a big part of it. And then in the microgrid space, there's a pretty big band there, and that really relates to the amount of energy storage. So I think if you're looking at doing a microgrid, a phased-in approach, starting with just energy store or just PV or wind, a small penetration, 20% or less, and then migrating over time to the energy storage options, which add cost to the project, probably makes sense. So more of a phased-in approach to the microgrid. So what's CAT doing about microgrids? We're really proposing and developing an integrated solution. We really believe there's value in having a CAT-branded, CAT-warranted solution that's supported by the dealer network globally. We've really reached out across the industry to try to find the best technology in each of those categories. We've working with First Solar on the Thinfilm. We're working with SMA on the inverters. But the idea here is to really factory engineer instead of custom build every microgrid, really factory engineer a solution for our customers. We test that, we prove it out, we use a consistent Lego block kind of design so that it's very scalable, but we really don't want a lot of build each project for a customer differently than every other project. So our intent here is to really have a CAT engineered and consistent solution globally. All the components will be CAT branded and warranted, supported by the CAT dealer network. Very scalable in terms of from the smallest, even village microgrid, all the way up to 15, 20, 25 megawatt microgrids for mines. Service support from our CAT dealers, parts availability across the globe. And then one of the things that we found is that financing, if we can get to a consistent solution, ones that banks can be comfortable with, and we've replicated it time and time again, we think we can provide better financing rates on these types of projects. I want to talk a little bit about Thinfilm. We're pretty excited about the technology. We believe it is a next generation technology over kind of the multi-crystalline panels that are out there. The big thing about it is it does have superior energy yield. It is more tolerant to shading than some of the other technologies, benefiting in some efficiency improvement. It also is less or has a lower coefficient on temperature, so that from an ambient temperature standpoint, the efficiency stays higher. And then from a spectrum standpoint, it tends to operate in high humidity areas and provide higher efficiency. So depending on where you're operating in the world, we've seen benefits ranging from 10 to 15% in terms of more energy yield, which is really what's important when it comes to solar. We've got over 10 gigawatts of that product installed, highly reliable, highly bankable, And from an efficiency standpoint, what we really like about thin film is where it's at today. You know, in the past, it was always behind the multi-crystalline panels in terms of efficiency. That's not true anymore. It is at those efficiency levels today. And just recently was announced that we'd see around 18% efficiency, about a 20% improvement over the next several years that's been proven out with the thin film technology. So we really think from a technology standpoint, it's the right product to go with. Talk about energy storage real quickly. You know, we're intending to be a full service provider of energy storage options to the industry. We think this is a very disruptive technology longer term to our core businesses. But whether it's ultra caps for just a few seconds of energy ride through for, say, a virtual spinning reserve application, or flywheel technology for maybe a few minutes or 10 minutes of ride through, or lithium ion energy storage for an hour to 4 hours of ride through, or zinc air, metal air technology for 8 to 48 hours of time shift energy storage. We're really working with all of those different storage providers to provide the optimum solution for the application. Caterpillar's designed a bidirectional inverter that basically allows you to plug and play the energy storage, whatever energy storage is needed into that application. It was developed using our D7H, our hybrid technology we use in our construction equipment, and also technology we use in mine trucks today. Finally, I want to talk about Cat Connect. I talked about the Internet of Things. We've got about 300,000 pieces of equipment connected today. We expect to connect everything in a microgrid into that same system. Many of you are familiar with it under a different name, MineStar. But the intent here is to really collect a lot more data, collect all the data off those machines, and then use data analytics to improve the life of our equipment. And also really move into beyond just equipment management to productivity improvements, safety improvements, and sustainability improvements as we move forward. So again, all connected through the same ecosystem as our current products are connected to today. From a security standpoint, I think offers some advantages. So with that, we're here really to be partners with the miners. We think and what we're trying to do is really provide more of an integrated, reliable solution to the industry, Cat branded, Cat warranted, scalable, a Lego block or building block sort of a design, so we can go from very small to very large, leveraging our technology and generator sets and control systems and hybridization of our equipment to really provide a good solution. The higher energy capture PV modules, the global reach, but yet local execution capability and product support from our dealer network. The repeatable type design, which I think will leverage financing. And then finally, Cat Connect, and I guess I'm here to say we really want to work with all the mines to understand what we can do with all this data that's coming off of all these different elements. And it's beyond just looking at microgrids. It's looking at your trucks and how much efficiency we can improve overall with autonomous vehicles to really help you be successful. So that's our goal. Thank you.